Good afternoon, everyone. In this video, we will present our task of data sentiment analysis in the data meaningful. First of all, let us introduce ourselves first. My name is Artini Artalia with the last digit of student number 072, and my friend.
My name is Ketut Dian Suryasih with last 3 digits student number 031.
And my name is Wayan Putri Satya Uttami with the last 3 of student number is 065.
Okay, so in this sentiment data analysis, we use hospitality data, total 1,000 data consists of column, text, and sentiment. The first step after exporting the data is import and install the requirement. In this case, we import the TensorFlow STF, after that the requirement package. And after all requirements are installed, we can continue with reading the data. In this reading the data set, we use F 50. So the model will learn from the 50 times or 50 training rounds. For the batch is 32. So the data will be trained in a small group of 32 data at a time. For the learning rate, we use 1e minus 6. So the learning rate of the model is set very small for the more stable rate of it. And for the max length is 256. So the maximum length of each text or sentence or review used to train the model is 256 words. So this is the model path, and the next is reading log. So we use the file path is the content slash dataset slash processed hospital review.csv. So the dataset is read from the CSV file and stored in the DL variable. And the next step is data separation is done before. After reading the dataset, we continue to model configuration. The first step in model configuration is load pre-train Albert model. So this code is to load tokenizer of the Albert model and load the pre-trained Albert model for text classification. The next step is processing data, tokenization, and padding. So this code is used to prepare text data to be understood by the Albert model. The next step is label processing. This code is create a label mapping that converts sentiment categories or label into numbers so that they can be processed by a computer or model. We have 3 labels here. Positive is 0, negative is 1, and neutral is. After label processing, we continue to normalize and convert label to numeric. This code is used to normalize the text label and convert them into numbers according to the label mapping that has been created previously. If there is an incorrect label, the value will be -1 to be corrected. And the next step is validate label. So this code is used to check and display the unique label existing categories in this training and testing data after being converted into numbers. This code gives an idea of what categories are present in the dataset and whether they are all correct or if there are any errors. The next step is handle invalid label. This code is used to check if there are any invalid labels in the training data or the test data. If there are invalid labels, the program will give an error message and stop the running. And the next step is class distribution. This code is used to count the number of labels in the training and testing data and display the result. This helps understand the class distribution in the data, whether it is balanced or not. And the next step is compute a class weight to handle imbalance. This code is used to calculate class weight that are used to handle data imbalance issues. The last step in the data set for training and testing. This code is used to create a data set that can be used to train and test the model. This data set will process using TensorFlow so that the model can learn from the training data and make to the test data. So all the explanation about the reading data and model configuration. For the next explanation will be continued by my friend.
Thank you, Artini. So after we reading the data set and also the model configuration, we will train and test the model. The main function of the train and test model as a whole is to train and evaluate the model's performance in solving the problem. In this case is sentiment classification. So the goal is for the model to learn patterns or relationship that exist in the data, which allow the model to make prediction on the new data. In here, first, we set the optimizer. We set it, we use Adam. Adam is a common method to help the model learn efficiently. And also we tell the learning rate. And then we prepare the model. And then we start training the model. So we use model fit to train the data set in batch, which is 32 and epoch 50, and validation test, and also the class weight is defined. So at each epoch, the model will make prediction based on the training data and calculate the loss or the prediction error, and then update the weight in the model using optimization, the Adam optimization. And because we use epoch 50, so the model will pass the data or iterate or check the data for 50 times. Once the model is trained, then we need to evaluate how well the model works on the data that has never been seen before. In here, this evaluation returns to result. Eval result 0 is the loss on the data set to measure how well the model reduces prediction error. And equal result 1 is the accuracy of data set. It is percentage of correct prediction. And then these two values are print to show how well our model works on the test data. And after we click run, it will starting to run per epoch. And then the result, the evaluation result, the test loss is 0.11 and the test accuracy is 0.91. It is quite high. It is high. About 91% is accurate. And in our opinion, there are several things that makes this make sense. So first, class imbalance. Like for the example, if we only have more positive review than neutral or negative, this can lead to bias the model towards the majority classes. So with the class weight, the model focus more on learning from underrepresented classes, and then thus improving performance across all the classes. The next, the second thing that makes it high in accuracy, maybe because we choose right optimizer and hyperparameter. So we use small learning rate. It is helping the model to learn slowly and reduce the risk of overshooting and ensure training stability. And we also use optimizer Adam. We know that Adam is one of the best optimizer for deep learning because it is adaptive to the learning rate, and maybe because the batch size 32 and epoch 50 is the sufficient combination. So this is allow the model to learn without overfitting. And the last but not least reason, maybe because we use good data set. Good data set is the relevant data set. So it is specific for the hospital review. So the patterns learned by Albert from retaining are relevant to this data set. And if the data set has clear pattern, maybe like specific word for positive or negative sentiment, I think Albert can learn this pattern quickly. And that's all about the training model. Next, before we are making prediction, we want to evaluate the performance of a classification model. We use a confusion matrix. So this code compares the prediction result given by the model with the actual values. So in other words, the confusion matrix helps us to see how well our model classifies the data. In here, first we determine the classes. It is positive, neutral, and negative. And the code get the correct answer from the test data set. The test data set contains the data that we already know the answer to, and we want to check how accurately our model predicts. And the model makes prediction against the data, and sometimes model provide its result in the form of dictionary. So we make sure we use only the correct results, which are the raw values from the model. And then we determine the prediction result classes. If the model gives only one value per data, then we consider prediction over 0.5 as class 1 or positive, and the less than that as class 0 or negative. But if the model gives more than one value, we select the class that has the highest value. And then we print the result. So it show that the classification report show an accuracy of 0.94. This means the model correctly predict about 94% of the entire data set. And precision measure how often a positive prediction is actually positive. And for positive class, precision is 0.83, meaning that of all the data predicted as positive, only 83% were truly positive. And I think that's all for me. For the next explanation will be explained by my friend Dian.
Okay, thank you, Ta. So next, I will continue the explanation about the visualization. So this code is used to visualize the training result model by using two graphics that show accuracy and loss during the training. And this visualization used to show training and validation accuracy grows as the epoch increase. And here we can see here is the model is overfitting or underfitting. Overfitting will occur if the accuracy on the training data increases significantly, while the validation accuracy does not increase or it is decreases. And then the underfitting will be seen if the training and the validation accuracies are both low. And in graphic here, the accuracy and the validation accuracy grows regularly, which is it is from the bottom and then regularly goes to the top. And it is not a growth like significant like this. And then for the loss graphic show that the training and the validation data decreases as the epoch increase. If the training loss decreases but the validation loss increases, this could be a significant of overfitting. If both losses are high, then the model could be underfitting. So by using this graphic, it makes us easy to see how the trained data grows as the epoch increase. And it is also make us easy to see is there a problem like overfitting or underfitting. Next, I will explain about the making prediction. So here, the prediction is used for the trained model that has been created before. And here, a new text is a list of the text that will be predicted for sentiment using the trained model before. This text is described review or comment that will be categorized into positive, negative, or neutral. And the tag then goes through the tokenization and padding to match the input format required by the Albert method. I mean Albert model. And the model then generates logits which show the score for each class, which is sentiment. Then the highest score is used to determine the predict sentiment label. Then the predicted numerical labels are converted back into the sentiments, which is in this case positive, negative, or neutral. And here we use 6 sentiment or text to predict. And the first is facilities are clean. And the predicted sentiment output is positive, which is a match with the sentiment context. And the second, the service was excellent, which is here positive, and it is also matched with the context. And the staff were rude and unhelpful, and here negative. And the experience was fine overall, and here neutral. And the quality of service was good, and here positive. And the service was disappointing, and here negative. So we can see here the predicted result is matched with the sentiment context. And the model that has been trained before is able to predict sentiment quite accurately based on the word in the sentence. Overall, this prediction showed that the model can identify the sentiment well based on the pattern learned during the training. And that's all from me. I will give back to Artini. Thank you.
Okay, Dian. So it's all for our group presentation about the sentiment analysis using 1,000 data with the accurate result is 0.90. Thank you.